This question, I call it as type 3 question. Where is my space? I look a little better. Okay. This question, I call it as type 3. So far we have done 2 type of questions. Right?
Yes, sir.
Actually, this is also type 2. But yet I call this as type 3 because there is some difference between this question and the type 2 question. If you remember, the type 1 question was to factorize. Type 2 question was to factorize. And for factorizing, there was a divisor given. A divisor was given. Is this okay?
Yes, sir.
This question is also almost same only. We have to check the divisibility of this number by this number. Right? That means this is a divisor. It's a divisor. And this needs to be divided.
Yes, sir.
This needs to be divided, that means this needs to be factorized. We have to understand the meaning of the divisibility and then the factorization. These are not 2 different words, it's same only.
Yes, sir.
So type 2 also it was same. Type 2 was to factorize this number having a factor. And that we did by division.
Yes, sir.
That we did by a actual method of division. Is this okay?
Yes, sir.
Now this time we are given again a algebraic expression and then we are asked to divide it by the given one but without actual division. Without actual division. And that is why this question becomes different from the type 2. Because in type 2 we did it by division. Now we are not allowed to do the division. But we have to check the divisibility of this number by this number without actual division.
Yes, sir. Yes, sir.
First of all, if the question is clear, no, then you will enjoy.
Yes, sir.
Okay? Again, I am repeating that type 2 question was the same type question and then we were allowed to divide it. We were allowed to divide it. The question was to factorize that given expression by actual division. So we followed the division method and then we found the factors. Because yesterday I said if 8 is divisible by 2, if 8 is divisible by 2, then 2 can be said to be a factor. Divisor is also said as a factor, right?
Yes, sir.
If 8 is divided by 2, then 2 can be said to be a factor. Now, if 2 is one factor, then what is the other factor? For that, we divide 8 by 2. And then we get the another factor, 4. And we say that another factor is 4. This is by division method. This is by actual division method. We divide the number by a factor and then we find another factor. This is what we did by actual division method yesterday.
Yes, sir.
Today we have similar question, but we are now not allowed to divide. We have to factorize this, or we can say we have to check its divisibility by this number without actual division. Is the question clear?
Yes, sir.
So, how can we do that? We are not allowed to divide it. We can check its divisibility by this number, or we can factorize this number by actual division method. But we are not allowed to do that. We are not allowed to do that. Is it okay?
Yes, sir.
Since we are not allowed to do the division, so we will go to the remainder factor theorem process. We will go to remainder theorem or factor theorem process and we can factorize. We can factorize or we can divide. Is this okay?
Yes, sir.
Now, if we want to go for factor theorem or we want to go for remainder theorem, then this cannot be accepted because this is given to you in the quadratic form. This is given to you in the quadratic form.
Yes, sir.
When you apply the remainder or the factor theorem, your divisor used to be always in the linear form. X minus 2, X plus 1, something like that, no?
Yes, sir.
So when I say X plus 1 or X minus 1, the degree of this X plus 1 or X minus 1 is how much? 1. And that is why we call it as linear. The divisor was always a linear function. And so we could apply the remainder theorem or factor theorem. Please be very mindful. Okay?
Yes, sir.
Where is your attention? I can see you are busy with your nail. So for the remainder or factor theorem, there is a restriction, we can say, that the divisor or the factor has to be in the linear form. Has to be in the linear form. But right now, we want to use, because we are not allowed to go through the actual division method, so we have to follow factor theorem method. But for factor theorem method, this part needs to be in the linear form. This part needs to be in the linear form. Is it okay? So first of all, we are going to do some correction in this part, and we will convert this into linear form. This is right now in the quadratic form. Is it okay?
Yes, sir.
So converting a quadratic into linear is very simple, because we know now factorization. We know factorization. We have learnt in class 10, and also we have learnt in class 11 how to factorize a quadratic in trinomial. Quadratic in trinomial. This is a quadratic, and there are 3 terms. So we know the process of factorizing it. Can you tell me what is the name of method of factorization? Expanding the middle term. Very smart. So I'm going to do it. X square minus x minus 2x plus 2. This is how it is factorized. And then group it. It becomes x of x minus 1 and minus 2 into x minus 1. Therefore, this is x minus 1 and then x minus 2. So we got the factor now. Okay? And from this, now we can have the value, from this part we can have the value of x, and from this part also we can have the value of x. Is it okay?
Yes, sir.
Now, let me show you one thing. This is a number. How much is this? 135. 135. Now, these are the 2 divisors. Or I will change it. 3 and 5. Is it okay?
Yes, sir.
3 and 5. Now, this number is divisible by 3. 135 is divisible by 3. This number 135 is also divisible by 5. Is it okay?
Yes, sir.
This is divisible by 3. This is also divisible by 5. It means this will be also divisible by 15. So, this is because 15 is what? Is the LCM of 3 and 5. If this number is divisible by 3 and 5 both, that means this can also be divisible by the LCM of these 2 numbers. Are you getting me?
Yes, sir.
Now, I said that this is the LCM of this number. It's very easy to prove that this is the LCM of this number, because you know how to find the LCM.
Yes, sir.
You know how to find the LCM. LCM we used to find, we are calculating normally by prime factorization method. By prime factorization method. Is this okay?
Yes, sir.
In the prime factorization method, by finding the common factor, we used to divide, and then hence we get the prime factors, and we used to calculate the LCM.
Yes, sir.
I'm not talking anything new. This prime factorization method, we are using it from class 4 level only.
Yes, sir.
Is this okay?
Yes, sir.
Now, at times, you are trying to calculate the prime LCM of any 2 number who do not have the common divisor. That is possible. You are calculating LCM of 2 numbers who do not have the common divisor. Example is 3 and 5. If I am asked to calculate the LCM of these 2 numbers do not have common divisor, what is the use of using the prime factor method then? The way you are quiet, as if I am talking something very, very difficult, or you are hearing for the first time.
Yes, sir.
These are the 2 numbers whose LCM has to be calculated. Normally we go for the prime factor method, but for this pair of numbers, no need to go for prime factor method because there is no common divisor.
Yes, sir.
In that case, what we do is we just multiply directly and get the LCM. We multiply and get the LCM. Is it okay?
Yes, sir.
Same concept now we will use. We are going to divide this number. We are going to check the divisibility of this number by this number. Right?
Yes,
To do that, we have factorized that part into linear form. Is this okay?
Yes,
Now this has got 2 factors, x minus 1 and x minus 2. Is this okay? Yes, sir. Now we will use the remainder theorem, factor theorem. We will use the factor theorem, and we will try to check whether this is divisible by x minus 1 or not. If this can be divisible by x minus 1 and this can also be divisible by x minus 2, that means this is also then divisible by the given expression. Is because this is the LCM of this and this.
Yes, sir.
Because what is this? This is the product of this and this.
Yes, sir.
Just now I gave you the example, no? 15 is the product of 3 and 5. So if any number is divisible by 3 and also divisible by 5, that means that number can be also divisible by 15. So we'll use this concept. Okay? We are asked to divide this number without actual division by this number. So we are going to use the concept of factor theorem. And through the factor theorem, we will prove that this is divisible by this and this is also divisible by this. And if this can be proved, then we will conclude, we can say also that this also becomes the factor of this and hence it is divided.
Yes, sir.
Have I understood now?
Yes, sir.
So, we'll try. First of all, we'll assume this is equal to px. Right? Now we'll take the first factor. From the first factor, the value of x will be how much? Positive 1. Very good. So, p at 1 is equal to 2 into 1 to the power 4 minus 6 into 1 to the power 3 plus 3 into 1 to the power 2 plus 3 into 1 minus 2 is equal to. If this becomes 0, then we will say that this is the factor.
Yes, sir.
So 1 to the power 4 means 1 into 2, 2 minus 6 plus 3 minus 2. 3 plus 3, 6 minus 6. Out. 2 and minus 2 out. How much is this? 0. So that way we can say that x minus 1 is the factor, no?
Yes, sir.
Now we are going to prove the other factor. So p at 2 now. 2 into 2 to the power 4 minus 6 into 2 to the power 3 plus 3 into 2 to the power 2 plus 3 into 2 minus 2. Okay. This will become 2 to the power 5, 32. 2 to the power 3, 8, 6 are 48. 4 3 is 12. 3 2 is 6 minus 2. Is it alright? Okay. 32 plus 12, 44 plus 6, 50. Minus 48, minus 2, minus 50. Wow, wonderful. Now we can say, since the given expression is divisible by x minus 1 and x minus 2, therefore the expression is also divisible by x square minus 3x plus 2. Understood? So we can say, since the given expression is divisible by x minus 1 and x minus 2, so it is also divisible by x square minus 3x plus 2. Alright?
Yes,
Thank you. Now, it looks a little similar like question number 15. But there is a difference. The difference is, in question number 15, you are asked to factorize a given expression with a given factor. And if one factor is given, then factorizing is very easy. Whether you do it by factor theorem or you do it by division method, in both the way it is very easy. Because I know one factor, so another factor I can easily find out. No? If 4 is one factor of 20, then what is the other factor? It's very easy. 4 is a factor of 20 and the another factor is very easy then. If 4 is one of the factors, then what is the another factor of 20? 5. How did you know this? By? You know the answer, but you don't know the process, how you get it. I want you to have confidence, my dear. Speak with confidence, not with a fear. Not with a fear. It by dividing, by division, isn't it? But what to do if I don't know one factor also? If I don't know one factor also, how to write the factor? Expanding. Wow, very good. How will you expand this 20? Okay, in this case, what we will do is, because we are asked to find twice, so finally we will go for all the factors of 20 now. No choice. They are simply asking us to factorize. Which factor? We don't know. Any factor. Any number which can divide this will become the factor. So we will have all the possible pair of factor of this 20. So maybe it will be 1, 2, 4, 5, 10, 20. All these are the factors. All these are factors. They simply told us to factorize. So we have factorized it now. So one pair of factor will be 1 to 20, 1 into 20, then 2 into 10, then 4 into 5. Is this okay or not?
Yes.
Not only this much. It could be plus or it could be minus. It could be plus, it could be minus. Plus, minus, plus, minus, plus, minus, plus, minus. You know why? Because the product is positive or negative, right? It depends. It could be positive, it could be negative also. But right now it is positive. Okay? Right now it is positive. Maybe this is the product of two positive quantity, or maybe this could be the product of two negative quantity. In both the case it is positive. So we don't know exactly whether this is the product of two positive quantity or two negative quantity. That is why I have taken all these numbers with both the signs. So that will be at the safer side. And nobody will challenge us also. If I tell you that this is the product of 1 into 20, then somebody will say, no sir, I don't agree with you. Maybe this could be the product of minus 1 into minus 20. And I have to accept it. Why to listen you? That is why I have taken both the signs. Is this very clear?
Yes, sir.
So, somehow this type of concept only we will use for factorizing this number. But discussing and explaining to that 20 was very easy because it was a number. We are very comfortable with the number system. But that way we are not very comfortable with the algebraic expression. But the process also goes in the same manner. Is it all right?
Yes, sir.
So, to factorize this, we will take this number because we are comfortable with the number system only. So I will only look at, because this is the only part where we have only number. So we will take only this part and then we will write all the possible pair of factor of this 30. Is it okay?
Yes.
So the possible factors of this 30 will be 1, 2, 3, 5, 6, 10, 15 and 30. Now this could be positive or negative, positive, negative, positive, negative, positive, negative. Is it okay now?
Yes,
Now here the number is negative, but still I have taken all the numbers with positive and negative sign is why? The reason is this number is negative. This number is negative. So when I say this is the product of one positive and one negative quantity, it is very clear. It is very clear. But when I multiply 1 and 30, I get the product 30. But out of this 1 and 30, which one is positive, which one is negative? This we don't know.
Yes,
Understood?
Yes,
So if I take this to be positive, then this will be taken negative. If I take this to be positive, then this will be taken negative. That is why the possibility is both. And that is why here also I have taken all the numbers with both.
sir.
Is this okay or not?
Yes, sir.
Now, this is just a hint. This is just a hint. Okay? Now, we are taking the whole algebraic expression. These are the values of x. These are the values of x. Is it okay?
Yes, sir.
So, for this algebraic expression, the factor is hidden here in this group only. From this many, we will have some factors of this expression. From this given set of number only, we have to find out which of them are the factor of this whole number.
Yes, sir.
These numbers we have derived from this constant. Okay?
Yes, sir.
But this only will now solve your problem also for the given expression.
Yes, sir. Yes, sir.
Is it alright?
Yes, sir.
So now how do we know? For the number 2 we know that all these are the factors. But for this whole expression, all this cannot be the factor. These are the factors of this number only. But from here only you are going to get the factor for the whole expression also. But all these numbers cannot be the factor of this expression. Is this very clear?
Yes, sir.
Now what is the degree of this? 3. That means you will have how many factors? 3. And you have how many numbers here? See. 1, 2, 3, 4, 5, 6, 7, 8. And 8 to the 16. Because positive negative both you have to see. No?
Yes,
So
sir.
total there are 16 number. Here total there are 16 number. Out of this 16 number, any 3 of them only can be the factor. The remaining will not be the factor of this expression. Because you know what is the number of factor of a algebraic expression. The number of factor of algebraic expression will depend on the degree. And this expression is in degree 3. So this will have only 3 factors. We have 16 possibility, but all the 16 cannot be the factor. The statement will become wrong. Am I right or not?
Yes, sir.
So from this 16 number, now we have to experiment one by one, and we have to find out the correct 3 number which can be the factor of this given one. We don't know which of them will be the right answer, but from this 16 number only we will get 3 factors. So we have to now try it with all the 16 number. Sometimes this question becomes very lengthy, and for that we will use the factorization method. Factor method. Factor theorem method. Is this okay?
Yes, sir.
So we will try this method. We call it as trial and error method. Hit or trial method. You try with one number. You take one number from here and then you put it for x. Then solve it. If it becomes 0, then that number will become the factor. If that does not become 0, that number is rejected. It is not a factor. Is it alright?
Yes, sir.
So I will show you some. So first of all, I am going to take the value of x as equal to plus 1. I am going to take the value of x as equal to plus 1. So x is equal to plus 1. Then when you write this in the factor form, that plus 1 will come to left side. It will become x minus 1.
Yes, sir.
Isn't it?
Yes,
This is just to keep in mind. So I am going to take this as x is equal to 1. So for this will be written as px is equal to this. Now first I am going to take the plus 1 value. So p at 1. Let us see whether this number is going to be the factor or not. So we'll put it here. 1 cube minus 19 into 1 minus 30. 1 cube means 1. 19 ones are 19 minus 30. This is 49 and then 1 plus 1. This is minus 48. Is this 0?
No,
That means 1 is not the factor of this given expression. Out. Now we'll try for negative 1. P negative 1. This is negative 1 cube minus 19 into minus 1 minus 30. This will remain negative. Minus 1. This will become positive. 19. This is minus 30. So 30 and 1. Both are negative. So 31. 31 and then minus 19 is minus 12. This is also not 0. That means minus 1 also is not a factor. That is why we call it as hit and try method. Is this okay?
Yes, sir.
I'll go for now 2. Another value. P at 2. So 2 to the power 3 minus 19 into 2 minus 30 is equal to 8 minus 38 minus 30. This is equal to 68 and then 8 minus 60. This also is not the factor. P at minus 2 is equal to negative 2 to the power 3 minus 19 into minus 2 minus 30 is equal to. This will become negative, right?
Yes,
This is
sir.
negative 8. This will become positive, 19 to the 38. And this is minus 30, minus 30. Okay, this is 38, and this is minus 8 minus 30, minus 38. Wow, we got the first answer now.
Yes, sir.
Isn't it?
Yes, sir.
So, this is x is equal to minus 2, no?
Yes,
That means what could be the first factor? Because x is equal to minus 2. So what could be the first factor? X plus 2. Very good. So I am writing here in this corner. I have to start correcting now. I got the first factor now. Is it alright?
Yes, sir.
I will go for p at minus 3. Let me try.
Yes, sir.
So it is equal to negative 3 to the power 3 minus 19 into minus 3 and then minus 30 is equal to, this will become negative, right? 27. This is negative 27. This will become positive minus 57. Sorry, positive 57. This is minus 30. This is equal to 57 minus 57. Wow. We got another factor also.
Yes, sir.
Right? So this is x is equal to minus 3. So your factor will be how much? X plus 3. X plus 3. How many factors this will have? 3. You got 2. You need one more. Okay? Can I go for 4 is not there. Can I go for 5?
Yes, sir.
5 cube minus 19 into 5 minus 30. 5 cube 125. 95 are 95. Minus 30 minus 30. 125 minus 125. Wow. X is equal to 5. So what is the factor?
X
minus 5. So x minus 5. So we will say required factors are this. Have you understood?
Yes, sir.
It was a really interesting question, no?
Yes, sir.
Thank you.